Today's topic is national income, where it comes from and where it goes. Today you'll learn what determines the economy's total output, thus income, how the prices of the factors of production are determined, how total income is distributed, what determines the demand for goods and services, and how equilibrium in the goods market is achieved. The material in this chapter is the basis of much of the remaining materials we'll get to later. So try to learn the models very thoroughly. Today, we are learning a relatively straightforward classical model of the real side of the economy, a closed economy market clearing model. On the supply side of the model, we have factor markets, and in the market for these factors such as capital and labor, there's supply and demand, and the price is determined when supply meets demand. And also on supply side, there's determination of output and income. And on demand side, there's determinants of consumption, investment, and government spending. And at the end, there's equilibrium at the goods market and the loanable funds market. And it is useful for you to keep in mind the big picture as you learn the individual components of the model. And here we assume for simplicity there are two factors of production, capital, K, for example, tools, machines, and structures used in production, and labor, L, for example, the physical and mental efforts of workers. Our simple production function shows how much output Y the economy can produce from K units of capital and L units of labor, and it reflects the economy's level of technology and exhibits constant return to scale. Our simple production function, Y equals F of K and L, depicts the relationship between capital and labor and the output. And initially, let's say output Y sub 1 equals to F of K sub 1 and L sub 1. And then let's scale all inputs by the same factor Z. In other words, you multiply K sub 1 times Z, you get K sub 2. Similarly, you multiply L sub 1 to Z to get L sub 2. The Z could be, for example, 1.2. Then you can see that this will increase inputs by 20% from initial level. And when it happens, output changes according to the production function. That is, Y sub 2 equals to F of K sub 2 and L sub 2. And when we say we have constant return to scale, then what it means is that when you multiply by Z to both inputs, output should be equal to Z times initial output level. Therefore, Y sub 2 equals to Z times Y sub 1. For example, if we substituted 1.2 for Z, then Y sub 2 should equal to 1.2 times Y sub 1. Therefore, when you scale up both inputs by 20%, then output should be increased by 20%. So if you have this kind of relation between inputs and outputs of the function, then we say there's constant return to scale. In other words, if there's constant return to scale, Y sub 2 should equal to Z times Y sub 1. On the other hand, when there's increasing return to scale, that means when you multiply both inputs by Z, increase in output is such that Y sub 2 is more than Z times Y1. And finally, if there's decreasing return to scale, Y sub 2 should be less than Z times Y sub 1. So to summarize, if there's constant return to scale, then Y sub 2 equals to Z times Y sub 1. Therefore, when you increase both inputs by 20%, output increases by 20%. On the other hand, if there's increasing return to scale, Y sub 2 is greater than Z times Y sub 1. So when you increase both inputs by 20%, output is increasing more than 20%. And finally, if there's decreasing return to scale, then Y sub 2 is less than Z times Y sub 1. So when you increase both inputs by 20%, output is increasing by less than 20%. Now let's look at an example. Let's suppose the production function f of k and l equals to square root of k and l. And now let's multiply both k and l by z. So if you multiply the inputs by z, you can substitute now into the equation. So under the square root, now k is replaced by zk and l is replaced by zl. And if you solve inside the square root, you have z squared kl at the end. So square root of z squared kl can be divided into square root of z squared times square root of kl. And square root of z squared should equal to Z. So it becomes Z times square root of KL. And square root of KL is nothing more than the original production function. Therefore, it ends up with Z times f of k and l. And it shows that at the end, when you increase both inputs by z, output increased by z. And in this case then, this particular function exhibits constant return to scale for any z that's greater than 0. Now let's continue with our simple model. In this simple model, we start by making the following assumptions. 1. Technology is assumed to be fixed. And 2. The economy supplies of capital and labor are fixed at k equals to k bar and L equals to L bar. That is, these are specific values of the two variables k and L. Then, output is determined by the fixed factor supplies and fixed state of technology. That is, y bar equals f of k bar and the L bar. Remember from chapter 2, the value of output equals the value of income. That is, the income is paid to the workers and capital owners, and so forth. Now we explore a simple theory of income distribution. Here, the distribution of national income is determined by factor prices, that is, the prices per unit firms pay for the factors of production. For example, wage equals price of labor, and rental rate of capital is the price of capital. Now before we proceed further, let's define a few notations. Capital letter W is defined as nominal wage, capital letter R is defined as nominal rental rate, P is defined as price of output, therefore W over P is the real wage measured in units of output, and R over P is the rental rate of capital. Now, since the distribution of income depends on factor prices, we need to see how factor prices are determined. So how do factor prices are determined? Each of the factor prices are determined by supply and demand in factor markets. For example, quantity of labor supplied and quantity of labor demanded. When supply of labor and demand for labor crosses in the supply and demand model for labor market, that's where the wage rate should be determined. And recall that supply of each factor is assumed to be fixed. Then if you plot the graph, the labor supply is vertical, where vertical axis should have real wage, W over P, and horizontal axis should have L, the amount of labor. So when we assume supply of each factor is fixed, therefore supply curve looks like vertical supply curve. What about demand? Here we assume markets are competitive and each firm takes nominal wage, nominal rental rate, and price of goods as given. And the basic idea here is that a firm hires each unit of labor if the cost does not exceed the benefit, that is, as long as marginal benefit is larger than or equal to marginal cost. Here the marginal cost would be real wage, and the marginal benefit would be marginal product of labor for each unit of labor. The marginal product of labor, MPL, is defined as the extra output the firm can produce using an additional unit of labor, holding other inputs fixed. Therefore, MPL equals to change in Y over change in L. And for a continuous production function, it can be expressed as a partial derivative, dy dl. As you can see in this graph, the marginal product of labor is the slope of the production function. Here, holding capital constant, in the horizontal axis you have units of labor, vertical axis as units of output. And as you can see, as more labor is added, the slope is getting flatter. That means as more labor is added, the marginal product of labor decreases. So many production functions have this property of diminishing marginal returns. That is, as a factor input is increased, its marginal product falls, other things equal. And the intuition is that suppose labor increased while holding capital fixed, that means there are fewer machines per worker, and this will lead to lower worker productivity. In terms of calculus, what you can see is when you take partial derivative of marginal product of labor with respect to L, that should be less than 0 or negative. That means as the firm hires labor L such that MPL equals to real wage, this means that the MPL curve is the firm's labor demand curve, and each firm hires labor up to the point where marginal product of labor is the real wage. That is, for each real wage, W over P, there's corresponding optimal labor, L star, through the MPL curve. Therefore, the MPL curve is the labor demand curve. Now, with fixed or vertical labor supply and downward sloping labor demand combined, we can see how the equilibrium real wage is determined in the labor market. That is, the real wage adjusts to equate labor demand with supply. Therefore, the equilibrium real wage is determined when L bar equals to labor supply that is equal to labor demand. In other words, when these two curves cross, there's where equilibrium real wage is determined. Now we have just seen that MPL equals to W over P. That is, marginal product of labor equals to real wage. The same logic shows that MPK equals R over P. That is, the marginal product of capital is equal to real rental rate. That is, the real cost of renting a unit of capital for one period of time. And similar to labor, it shows diminishing returns to capital. That is, as capital increases, marginal product of capital falls. So the MPK curve is the firm's demand curve for renting capital. And here too, firms maximize profits by choosing capital such that MPK equals to real rental rate R over P, the price of capital in real terms. Note that in our model, it is easy to think of firms renting capital from households who own all the factors of production. Of course, in real life, many firms own some of their capital as well. But for such firms, R over P, the real rental rate of capital, is the opportunity cost of using capital instead of renting it out. Therefore, you can also view that as the real cost of renting a unit of capital as well. That is the foregone rental income. So the graph looks very same. That is, the real rental rate adjusts to equate demand for capital with supply. Therefore, when the supply of capital and the demand for capital, that is MPK, these two plots cross. That's where the equilibrium rental rate of capital is determined. When K bar equals to quantity of capital supply, and that is equal to quantity of capital demanded. The neoclassical theory of distribution states that each factor input is paid its marginal product. That is, W over P equals MPL and R over P equals MPK, as we just saw. And it is a good starting point for thinking about income distribution. So how income is distributed to labor and capital? You can recall that households own both labor and capital, and the total labor income for households should equal to W over P, the real wage rate, times L bar, the number of units of labor the household provides, which is equal to MPL times L bar. Similarly, total capital income for households should equal to real rental rate, that is R over P, times K bar, which is equal to MPK times K bar. So, if production function has constant return to scale, then total income or total output is divided between the returns to labor and the returns to capital. That is, Y bar, the national income, equals to the labor income, that is MPL times L bar, plus the capital income, that is MPK times K bar. What this means in English is that the total national production is just exhausted as all factors were paid their marginal products. And I'll show you the derivation during live session. If you look at the historical data for United States, the factor shares of the income have been remarkably constant over time. And this was noted by Senator Paul Douglas and mathematician Charles Cobb. And they provided the functional form y equals to some constant a times k to the alpha times L to the 1 minus alpha. And this equation was become known as Cobb-Douglas production function, and it is most widely used production function in economics. And this particular plot is consistent with the Cobb-Douglas function's assumption of constant return to scale. So the Cobb-Douglas production function has constant factor shares where alpha is the capital share of total income, and 1 minus alpha then should be labor share of total income. Therefore, capital income should be equal to alpha times y, which is equal to NPK times K, and labor income should be equal to 1 minus alpha times y, which is equal to NPL times L. And as Cobb-Douglas production function says, y equals to a times k to the alpha times L to the 1 minus alpha. Each factor's marginal product is proportional to its average product. That is, NPK using Cobb-Douglas production function should equal to, that is partial derivative with respect to k of the Cobb-Douglas production function should equal to alpha times a times k to the alpha minus 1 times L to the 1 minus alpha, and that should equal to alpha times y over k, which is equal to alpha times average product of capital. Similarly, NPL should equal to, that is the partial derivative of y with respect to L should equal to, using Cobb-Douglas production function, 1 minus alpha times a times k to the alpha times L to the negative alpha, and that should equal to 1 minus alpha times y over L, and that's equal to 1 minus alpha times average product of labor. Finally, let's look at the data to see whether the model or theory is consistent with the real life. So what the model we derived tells us that people will be paid according to their marginal and average product, and income will also be distributed accordingly. And if you look at the table that shows US data of average annual rates of productivity and real wage growth, the theory seems to be matching closely with the real data in the United States. That is, while not equal, the two series are very highly correlated. So, as you can see, from 1960 to 1973, productivity growth was 2.9%, while real wage growth was 2.7%. But then you see that from 1973 to 1995, the productivity growth slowed down to 1.5%, and in matching with that, real wage growth slowed down to 1.2%. And then after 1995 until 2013, you can see that the productivity growth shot up to 2.3% again, while real wage growth also shot up to 2.0%. So you can see that the data is pretty consistent, seeing the match between average annual rate of productivity and real wage growth. That is, the wage depends on labor productivity, and it seems like the high association between these two variables gives an evidence to the theory. So far, we've looked at the supply side of the model, we looked at the factor markets, and the determination of output and income. Now let's continue with the demand side of the model. Look at the determinants of consumption, investment, and government spending, and then look at the equilibrium. So we assume closed economy model here, so there's no net export. And the components of the aggregate demand should be equal to C, the consumer demand for goods and services, plus I, the demand for investment goods, plus G, the government demand for goods and services. First, consumption, C. And we define disposable income as the total income minus total taxes. That is the income that you actually can use yourself. And the consumption function, C, of Y minus T, disposable income, shows that as disposable income Y minus T increases, consumption increases. That is, if you have more income that you can actually spend or use, you can actually consume more. And we have to define the marginal propensity to consume, MPC, as the change in C when disposable income increases by $1 or 1 unit. That is, change in C over change in disposable income. And the change in C over change in disposable income is nothing more than the slope of the consumption function. When you plot on the horizontal axis disposable income and vertical axis consumption, the slope is then MPC, which is change in consumption over change in disposable income. Next, investment I. The investment function, that is I, is of R, where R denotes the real interest rate, the nominal interest rate corrected for inflation, that is. And the real interest rate is the cost of borrowing or the opportunity cost of using one's own funds to finance investment spending. So I depends negatively on R. That is, when R increases, I should fall. That is, as opportunity cost for investment increases, the level of investment will fall. So as the spending on investment goods depends negatively on the real interest rate, you can plot this. That is, on the horizontal axis, you have I, investment, vertical axis R, real interest rate, and the plot of investment should be downward sloping, as spending on investment goods depends negatively on the real interest rate. Finally, government spending G. So G is defined as government spending on goods and services, and G excludes transfer payments, for example, Social Security benefits or unemployment insurance benefits. And we assume government spending and total taxes are exogenous. So at the end, the market for goods and services can be depicted in this way. That is, aggregate demand should be equal to C of Y bar minus T bar plus I of R plus G bar. And aggregate supply is depicted as Y bar equals to F of K bar and L bar. And at equilibrium, where aggregate demand equals aggregate supply, Y bar should equal to C of Y bar minus T bar plus I of R plus G bar. Notice that by our assumptions, every variable is fixed except the real interest rate R. So the real interest rate adjusts to equate demand with supply to clear the market for goods and services. That is, the real interest rate R is the only endogenous variable in the equation. Interest rate is also important in the financial market as well. So we develop a simple supply and demand model of the financial system. And here we assume there's loanable funds market, which is a simple supply demand model of the financial system. And we assume one asset, for simplicity, loanable funds. And demand for loanable funds is the investment, and supply of funds is related to savings. And the price of funds is the real interest rate here. So if you look at the demand for loanable funds, the demand for loanable funds comes from investment. That is, firms borrow to finance spending on plants and equipment, new office buildings, etc. And consumers borrow to buy new houses. And the demand for loanable funds depends negatively on real interest rate, because you can view the real interest rate as the price of loanable funds, that is, the cost of borrowing. So when the cost of borrowing increases, for example, then quantity demanded would fall, and vice versa. Therefore, there's negative relation between quantity demanded of loanable funds and real interest rate R. So if you draw the graph of it, then the loanable funds demand curve looks downward sloping. That is, the investment curve is also the demand curve for loanable funds. Now look at the supply of loanable funds. And supply of loanable funds is related to savings. That is, households use their savings to make bank deposits, purchase bonds, and other assets. And these funds become available to firms to borrow to finance investment spending. In addition, the government may also contribute to savings if it does not spend all the tax revenue it receives. So the two sources of loanable funds are, one, the households, and two, the government. And the private saving is related to households, that is, disposable income minus consumption would be the private savings. Similarly, public savings related to the government. In this case, tax revenue minus government spending would be public savings. And the national saving is the sum of private saving and public saving. Therefore, it should be equal to disposable income Y minus T minus consumption plus T minus G. And in this case, at the end, you see that T's cancel out. You have simple formula for national saving, S equals to Y minus C minus G. Now let's talk about budget surpluses and deficits. So if tax revenue is greater than government spending, then there's budget surplus, and there's positive public saving, T minus G. On the other hand, if tax revenue is less than government spending, there's budget deficit. That means government spending is larger than tax revenue, therefore the public saving is negative. Finally, if T is equal to G, that is tax revenue is equal to government spending, we say there's balanced budget, and public saving T minus G equals 0. Then the US government finances its deficit by issuing treasury bonds that is borrowing. This is the US federal government surplus/deficit plot since 1940s until 2016, where 2012 to 2016 are estimates. And you can know several things. First, the huge deficit in the early 1940s. This was due to World War II, and as you know, wars are very expensive. So US government borrowed huge amount of money to finance the war. But then after US won the war, the deficit decreased significantly and even went on to surplus for a while. And the budget was close to balanced in the 1950s and 60s. However, it begins a downward trend in the 1970s. And the early 1980s saw the largest deficits as percent of GDP of the post-World War II era due to Reagan tax cuts and defense build-up, almost the end of Cold War, and also the growth in entitlement program outlays. And what happened? The Cold War was over, early 1990s, and the budget begins a positive trend in the early 1990s, and a surplus eventually emerges in the late 1990s. And that's the era of dot-com stock bubble. And when the bubbles bursted, that's when the government had rescue packages, and the rescue packages was done through deficit spending. And you saw subprime mortgage crisis 2008 and 9. There was huge amount of deficit during that time. And recently, the budget deficit in current dollars has reached all-time highs due to a sharp fall in tax receipts and the enactment of multi-billion-dollar bailouts and large stimulus packages, that is, around 2009. But as I said, the government financed its deficits by borrowing from the public, issuing bonds. And as you can see, after World War II, when the US federal government debt was skyrocketed during World War II, but after World War II, it rapidly decreased and it hit the bottom as a percent of GDP around 1980. So after World War II, in the US, we saw occasional budget surpluses, and this allowed the government to retire some of its World War II debts. Also, normal economic growth increased the denominator of the debt to GDP ratio here, starting in the early 1980s, however. Corresponding to the beginning of huge and persistent deficits, we see a huge increase in the debt ratio from 32% in 1981, for instance, to 66% in 1995. And in the middle of 1990s, budget surpluses and rapid growth started to reduce the debt ratio, but it started rising again in 2001 due to the economic slowdown and tax cuts and higher spendings. And recent financial crisis and Great Recession has increased the debt ratio as revenues have fallen, while outlays like stimulus packages and bailout have sharply increased. Now let's go back to our loanable funds model. First, let's look at the supply curve. Based on our assumption, national saving does not depend on real interest rate. So the supply curve, if you plot it, it's vertical, as national savings does not depend on R. And that amount of savings is determined by real GDP Y, taxes, and government spending, which are all assumed to be some constant. That is the reason the supply curve is vertical. You see bars everywhere. The demand curve is downward sloping as seen before. And when supply and demand curves cross, we have equilibrium real interest rate determined and equilibrium level of investment determined as well. So we can use the loanable funds market, the supply and demand diagram, to see how the interest rate that clears goods market is also determined. So R has a special role. R adjusts to equilibrate the goods market and the loanable funds market simultaneously. And if loanable funds market is in equilibrium, then national saving S, which is equal to Y minus C minus G, should equal to investment. So therefore, Y minus C minus G equals I. And if you add C plus G to both sides, you can retrieve Y equals C plus I plus G, which is the goods market equilibrium condition. Therefore, it tells you that equilibrium loanable funds market also implies equilibrium goods market and vice versa. Now, this is an advice to you, the student of economics, to succeed. So in general, in order to master a model, you have to know, 1, which of the variables are endogenous and which are exogenous, and 2, for each curve in the diagram, you should know A, definition, B, intuition for slope, and C, all the things that can shape the curve. After you get all these, then 3, use the model to analyze the effects of each item in 2C. You'll see a lot of models in economics class, and many exams include questions requiring you to show how some events shift the curves, and then use the model to analyze its effects on the endogenous variables And following these steps really help you to figure out the answers to many questions in economics. Now with that notes, let's try to master the loan over funds model. So here, the things that shift the saving curve are, one, for the public saving, the fiscal policies, which changes G or T. Since public saving is T minus G, when G goes up, then public saving goes down, while when T goes up, public savings increase. So you know that when there's increase in T or decrease in G, then supply will increase and shift the supply curve to the right. For private savings, there are a couple of things that shift the savings curve. First is preferences. Another thing is tax laws that affect savings. For example, introduction of 401k would increase savings. IRA also increase savings. And tax laws that replace income taxes with consumption tax might also increase savings, as these are all incentives to save. Now let's look at a case study to regurgitate what we've just learned. Let's analyze the Reagan deficits with our model. So the Reagan's policies during the early 1980s consist of two things in terms of tax policies and government spending. That is, one, increase in defense spending. So they're fighting Cold War against Soviet Union, and there was huge amount of defense spending during early 1980s. This increased government spending a lot, and it has a direct effect on lowering public savings, therefore national savings. In addition, Reagan employed so-called Reaganomics, that is supply-side economics, that is, having big tax cuts to stimulate consumption. So the result is, both of these policies reduce national savings. As you can see, this national savings equation equals to y minus c minus g. So on the net, at the end, there's direct effect of increase in government spending that lead to decrease in national savings, and the effect of decrease in taxes, increase consumption, therefore decrease in national savings. That's the indirect effect on national savings via consumption increases. So Reaganomics meant national savings decrease in the loan over funds market. So graphically, that's depicted by leftward shift of the S-curve from S1 to S2. What happened? This will cause the real interest rate to rise from R1 to R2, which reduces the level of investment from I1 to I2. And when the increase in the deficit actually reduces savings, which cause the interest rate to rise, which reduces the level of investment, is known as crowding out effect. That is, the government purchase crowds out as real interest rate increases the investment. Therefore, on the net, there's less effect on increasing output than otherwise without crowding out effect. In other words, if you are able to keep the interest rate fixed, it wouldn't crowd out investment. But because real interest rate is increasing, there's some crowding out effect on investment. Now let's look at the data to see whether these results of the models are consistent with real data. And if you look at the real data for public savings, in 1970s, it was negative 2.2, but 1980s, it became negative 3.9. So what happened? Public saving actually decreased even further. And as you can see here, national savings fell accordingly due to fall in public savings. And your expectation is real interest rate increase, and that's consistent. As you can see, it increased from 1.1 to 6.3%. However, the investment did not fall as much as expected. That is, it didn't fall as much as the fall in national savings. If our model tells you the true story, this will be very similar to the amount of national savings drop, that is investment drop. So what's the problem here? What do you think is the reason the investment didn't fall as much as the fall in national savings? What do you think is the reason this didn't match? Yes, the answer is the US economy is not a closed economy, it's an open economy. Therefore, probably the shortages of national savings was fulfilled by the foreign investors who actually pour in their financial capital into the United States. to mitigate the effect of fall in national savings in dropping investment activity and fulfill the funds that needed investment. Now, why don't you take a moment and try to answer this question using the loanable funds model we just saw. First, draw the loanable funds diagram, that is, horizontal axis, national savings S, and investment I, and the vertical axis, real interest rate R. Then try to answer this. After you draw a vertical supply curve and downward sloping demand curve, that is I over R. Next, suppose the tax laws are altered to provide more incentive for private savings. So this is about incentive for private savings, and assume that the total tax revenue T does not change. So in other words, we assume there's no effect on public savings. So the idea is only it affects private savings. Then what would happen to the interest rate and investment as a result of this? So the key here is draw a supply and demand model we just saw, initial equilibrium, and then see which curve shifts which way. That's the key. So what do you think? Which curve shifts which way and why? Hint, yeah, it may affect the private savings. So what effect does it have on private savings? And which curve shifts which way then? What's the result on interest rates R and investment I? After you take a moment and draw the graphs with pencil and paper, look at the answer that I'm going to show you now. So initially you're at point A. What happened is the change in the tax law increased savings. So it shifts the supply curves to the right, and this will cause the real interest rate to fall from R1 to R2, from A to B. And this will increase the level of investment from I1 to I2, as savings increase from S1 to S2. Therefore, at the end, the interest rate decreases from R1 to R2, and investment increases from I1 to I2. Now let's look at the things that shift the investment curve. 1. Some technological innovations. To take advantage of some innovations, firms must buy new investment goods. Therefore, it will stimulate investment and shift the investment curve to the right. Second is tax laws that affect investment. For example, investment tax credit. This will also increase investment, so shift the investment curve to the right. So what would be the effect of this law? It would increase investment for a given interest rate. That's why it shifted the demand curve to the right. So as you can see in this graph, when there's an increase in investment, that is, investment curve shifts to the right, it raises the interest rate from R1 to R2. But the equilibrium level investment cannot increase because the supply of loanable funds is fixed. Therefore, investment stays the same at the end, while interest rate rises from R1 to R2. Now we can relax the assumption that is supply is vertical and let it vary with changes in real interest rate. Why my saving depends on real interest rate? Because 1. An increase in real interest rate makes savings more attractive and would increase the reward for postponing consumption. That is, people make intertemporal substitution between current and future consumption. Therefore, it would increase savings amount. Second, many consumers actually finance their spending on big-ticket items like cars and furniture, and an increase in real interest rate makes such borrowings more expensive. Therefore, it costs less borrowing, and the amount of savings may increase. However, an increase in real interest rate may also reduce savings through the income effect or wealth effect for net savers. That is, a higher interest rate makes net savers better off, so they purchase more of all normal goods. And if current consumption is a normal good, then it will rise and saving will fall. But usually, substitution effect is assumed to be dominating income effect, wealth effect. Therefore, on the net, the amount of savings would increase. So on the net, if the amount of savings positively depends on real interest rate, then how would the result of an increase in investment demand be different? Would real interest rate rise as much? And would the equilibrium value of I change? So as you can see in this new graph, where savings is positively sloped instead of vertical, an increase in investment demand would raise interest rate from R1 to R2, which induces an increase in the amount of savings, which will allow the investment to actually increase from I1 to I2. So when saving depends on interest rate, an increase in investment demand causes the equilibrium values of saving and investment to rise, and causes the interest rate R to rise, but not as much as when saving does not depend on the interest rate.